This is your second lecture of week 1. Now, on Tuesday morning, we mainly went through a bit about the basics, or especially the unit itself, how it's going to run, and what's going to happen, etc. But today, we are going to focus a little bit more about the MATLAB basics and using MATLAB itself, and that will be relevant for your lab next week. Now, I've checked yesterday. On Moodle, the unit guide has been uploaded. So again, if you have some time, just check it through. Make sure you go through it to see what's the unit about, what do we expect from you, etc. The first lab questions are already online. So again, on Moodle, if you go to the laboratory folder, there should be a folder for lab 1. And there's a PDF file in there with the lab questions. So for the first week, as in for the first lab, you will have 9 questions to do. That will be fairly basic. So again, if any one of you have had a chance to have a look at the questions, all 9 questions, you can actually solve them by hand. I would recommend you doing that. Again, it's just to make sure that you understand the mathematics behind it. Well, at least you can understand how to solve it just using pen and paper. In the labs, what your focus will be on is how to write that into a MATLAB code, or how to get MATLAB to solve it for you. So then you focus more onto writing MATLAB code as opposed to thinking about how to solve the problem. So you can do that beforehand. Also on Moodle, under the laboratory folder, there's another heading there that says student lab marking sheet. If you've seen that, it's basically, again, a PDF that has 9 boxes for 9 labs. And still playing up. 9 boxes for 9 labs. So this is your student marking sheet record. Now, what this is, every lab, if you remember, every lab will be an assessment. So once the demonstrator marks your work, if you have your sheet with you, they can record your mark onto that sheet and sign it off. So if ever, towards the end of a semester, for some reason you find out that the marks that you have online is wrong, or you're missing a lab mark, but you did attend that lab session, then that sheet will be what you will need to get your mark back. So otherwise, if something goes wrong, you might be losing some marks that you've done the work for, but you have nothing to prove it. So that's why you need to have this sheet. So jumping straight into MATLAB itself. Now, the first thing that we look at is a variable. Now, a variable is actually the backbone of every programming language. It doesn't have to be MATLAB. Any language that you're going to write a program in, one of the most important things of programming is a variable. Now, what is a variable? Obviously, the obvious explanation is something that is likely to vary. But essentially, a variable is, you can have it as a name or anything that is going to store information that you will use later. Now, you store information that you can use directly, or you can get the program to use that information to do some other task. You can also replace that information with something else. So when you write programs, every information that you want the computer to store, you have to store that in a variable. Variables is essentially what Facebook and Twitter is all about. So storing all the information, your name, your photos, or everything, is basically stored in variables. So without that, pretty much back to the caves. So as we have done you've done that in basic mathematics. We did some examples earlier this week as well. If, for example, say you have in algebra, we say Adelaide is 3 degrees warmer than Brisbane, and we call Adelaide A, and we call Brisbane B. So effectively, in mathematical terms, A equals to B plus 3. Okay? So if you have the value for B, so if we say Brisbane is 40 degrees to A, how hot is Adelaide? So it's simply 40 plus 3. So that's what variables are. So they store information. Here we have two variables. One of them is storing information about temperature in Brisbane, and the other storing temperature in Adelaide. And you can see how that the variable can actually vary. So you can change the temperature of Brisbane, and it will automatically change Adelaide. So if you run that into MATLAB, okay, so we'll just demo that quickly here. If I say A equals to B plus 3, so it will give me an undefined variable B. So that's because the computer doesn't know what B is. However, if we specify B equals to 40, and then we have A equals to B plus 3, now that will give us 43. Now, while I was doing that, there's three things that I've done that you might actually find handy when you write your own code. One is CLC. So what CLC does, it clears the command window. So it's basically going to clear, if I press enter, it's going to clear the command window. There's another command called clear. So if I press enter here, it's going to clear the command history, or clear all the variables from memory. Show you. Now, if I type A equals to B plus 3, right, it says it's undefined because it doesn't know what is B. If I have B equals to 40, and I have A equals to B plus 3, that will give me 43. If I type CLC, clears the command window, and again I do A equals to B plus 3. This time it works. Why? Because even what we've done here, we've just sort of erased the board, but we haven't erased the variable itself. So MATLAB is still storing the variable from before. All I've done is just made a blank screen. To actually erase all the variables from the memory, you need clear. So clear will actually erase everything. So these two commands are quite handy. The reason is, sometimes when you do the task, if you don't clear the previous variables and you try to do some calculation, MATLAB is taking the value from your previous variable. And then you get the answer wrong, and you don't know what's wrong with it, because it's taking like a number that you can't even remember. So it's always a good habit to always clear all your variables before you do a task. The other thing is I'm using, you see how I'm tapping very quickly? So what I'm actually doing is using the top arrow on the keyboard. So using the top arrow will actually go through all the previous commands that you've written. This is very handy when you want to try a few things repeatedly. So using the top arrow will give you the previous command. These are just little shortcuts that will make your life easy. So now that hopefully we've established that we do need variables, they are very important to us, we are going to use variables in every single task that we do in MATLAB. Every single task from now until the end of the semester will rely on variables. So MATLAB has some rules for naming variables. So the first rule is the variable names must start with a letter. So if you're naming a variable, it must start with a letter. Can't start with an alphabet or a punctuation. So any alphabet, it must start with that. That's rule number one. Rules number two is you can put numbers after the first letter. So once you have the first letter, then it doesn't matter. You can put numbers if you want, that's fine. the names must not have spaces. So for example, if you're writing test score, you can write them together, that's fine. If you put a space, MATLAB will not like it, so it will run into an error. So if you do want to put a space, what I suggest you do is use underscore. So it looks like a space, but it's actually not a space. You can't use any punctuation in variable names. So no dots, no exclamation mark, nothing like that. So these are a few rules for naming variables. If you don't follow those rules, MATLAB will not like you. MATLAB is case sensitive. So when you name a variable, all these variables, they are treated as 4 different variables. So MATLAB is case sensitive. So that's quite, again, important, because if you name some variable time, and then later down the code, you're using time, but you've used the wrong syntax, so you've used a capital or something like that, so MATLAB will not be able to find that variable. However, fortunately for us, fortunately for you, the new versions of MATLAB that you're using, or that you will be using in the labs, so anything from, I think, MATLAB 2011 or 2012 onwards, it's basically becoming a bit like Microsoft Word. If you have a variable called time, and later down the code, you've made a mistake in the syntax, it will underline it for you, and if you hover your mouse over that part that it underlines, it will try to be smart and tell you, did you make a mistake? So it's just getting a bit smarter. So when you choose your variable names, you want to try to choose, because again, remember, variables are essentially the backbone of any programming language. When you choose the names, it's best if you choose something that makes it easy for someone who's reading the code to understand. Like, as far as possible, try to use self-explanatory variable names. For instance, if you just wrote a code that said A equals to B plus 3, what is A, what is B, can be anything. You know, it doesn't tell us anything if somebody else is reading the code. However, if we write Adelaide underscore temperature equals to Brisbane underscore temperature plus 3, now the code in itself makes more sense. You could even write Adelaide underscore temp if you want to shorten it, because you don't want to go too far, right? You don't want to have names like this, because then it's just, you know, you're going to run out of lines on your screen. So what is the right amount of, or what is the right length of a variable name? Nobody knows. So you just get that in practice. As long as it sort of makes sense, but you get used to that as you go, as you write more codes, it makes more sense as to what to use, etc. So for example, if we're using a variable name to describe the car acceleration, so out of all those, I guess, you know, we can discard the last 3. They really doesn't mean much. However, the first 2 are okay to use. The first one is basically for a newbie, so anybody who has no idea what is acceleration, then you have car underscore acceleration, it will make sense to them. If you write car underscore accel, somebody who's never sort of like, you know, heard the term or done a bit of physics or math, they might not understand what is accel. However, if it's somebody from a science background reading this, actually it should be logical for everybody to know. So it should roughly mean, if you have car in front, then accel should be fine. We do have a bunch of other good programming practices. So again, the reason we write this as a good programming practice is because if you're trying to solve a problem, whether you write it as this or you write it as A, it will still solve the problem. What you're trying here is to get good habits into programming. So it's a bit like when you learn how to drive. You know, you learn all the good habits, then you pass the test, which means you pass Eng1060, and then you can do anything you want and write A. Doesn't matter. But we try to, you know, get through the, at least we know what are the good habits. It's always handy. We can use MATLAB as a calculator. So again, we've done that on Tuesday. But basically, all it is you go to the command window and you just type whatever you would type as you would in your calculator, and you will get MATLAB to give you the answer. However, you do have a MATLAB operator precedence. So for example, this is basically all the different operators that MATLAB has. Equal, the addition, subtraction. Multiplication is the star sign, which is like Excel. Division and power or exponentiation is again like Excel using the exponentiation sign. So if you have to, like we say you have to run the following code. So what does A and B contain? So what would A be? Anybody? Anyone? 5 or 3? How many things would be 3? Yeah? 5? Okay. What about B? What would B? Well, it doesn't matter what B contains because we've got to establish A first, right? Now, one of the things that you will notice here is basically this. So what we've done here is we reassign the same variable. The way that MATLAB will work is MATLAB works on a line-by-line basis. So it will execute the program one line after the other. So the first thing that MATLAB does is you've said A equals to 3. However, what MATLAB treats that, it's not really treating as if like A is equal to 3, but what it's doing is saying there is a variable A, and that variable A contains some information. The information that is in it at the moment is 3. So this is a box that contains 3 at the moment. The next line, we have a variable A. So whatever is on the left-hand side of the equal to sign is just a variable name. When it has A equals to, before it actually executes that command, it doesn't know what it is. All it is a variable, so basically a box, and we are going to put some information into that. The information that we put is given on the right-hand side. Now, what information are we going to put? Is we're going to put a variable A. So now MATLAB will go and look back. Do I have a variable A that contains some information? And the answer is yes, because it has it from the previous line. So it has 3 plus 2. So that's equals to 5. Now, this information of 5, it will store that into a variable. And the variable that it will store it in A. So what it's done now is it's overwritten the previous variable. So it overwrites it from 3 and makes it 5. The reason we do this is to try and be more efficient on the number of variables that we use. Because sometimes you will run a code that you only use that variable name once. And you only, let's say you only need that information to be able to calculate the next piece of information. And then you get the next information to calculate the third one. So all this information, you're using them once only. So if you're going to keep all your variables, then you will end up with a code that could have 1,000 unnecessary variables. So this time, you replace them it makes it a little bit more efficient. So yes, A will be 5. And B equals to same principle. So B equals to 1 at the moment. The next variable is 5 minus 1, which now becomes 4. So it replaces B by 4. So the way MATLAB does its mathematical operation, it follows this. Do you know what this is? Yeah? Does that ring a bell? BODMAS? Probably from high school. But effectively, it's bracket, order, division, multiplication, addition, subtraction. So when MATLAB does its operation, it will operate brackets first, order, which is basically exponentiation or power, and then what? Division, multiplication, and then addition and subtraction. If you're not too sure about whether it will do the power first or the division first or the multiplication first, you can just use brackets, extra brackets. But that's anyways the order of precedence. So once again, you can try those. So if you're going to run this code in MATLAB, it will operate the bracket first. So it will be x power 3 multiplied by whatever is in the bracket, which is negative 2. And then it will perform the order. So it will become x to the power 3, which is 2 to the 3, 8, multiplied by negative 2. And then perform the multiplication, which gives you negative 16. That's the order of what MATLAB would be doing the calculation. You can try that in your own time on the command window, just to play around with it a bit. So now, any questions so far about variables and using MATLAB as a calculator? So effectively, your next week's lab, all the questions are basically around just solving mathematical equations. Now, when you read the questions, don't be fooled about them, okay? When you read the questions, it's just a story. But effectively, it's quite simple. I mean, you have a storyline with it, but essentially all the questions are, you have an equation, and you have a bunch of variables or numbers that you have to put into the equation to give you the answer. There's a few challenges, I suppose, here and there. I've mixed up the units a bit. So if you have one question, I give you gravity is 9.8 meters per second, and then I give you height in millimeters. So you need to convert the height into meters, and then you do the question. All right? So there's a few bits like we're converting from miles, from yards. So it's just basically a bunch of equations for you to play around. So everything that you'll be doing in the first week will essentially be equations, numbers, and variables. And you can work around what's the order of precedence that the operation is done. However, MATLAB also has a number of inbuilt functions. As far as we're doing multiplication, division, and all, that's straightforward. However, when it comes times for us to do square root, to do cosine, sine, etc., then MATLAB has a bunch of inbuilt commands for that. And it has much more than just the basic ones. That's what differentiates MATLAB from other programming languages. So actually, MATLAB has been developed specifically for science engineering purposes. So what they've done is it's built upon C programming. In C programming, you have to write a lot of your own codes. So for instance, if you need to have, I don't know, just say for example, to do the remainder, you might need to write your own code to evaluate what's the remainder. In MATLAB, all of these are already there in the library for you. So what we call them is built-in functions. So you have like thousands of built-in functions in MATLAB, all of which we're going, not all of which, but a number of which we are going to learn as time goes by. So some of the basic ones that will be self-explanatory, SQRT, which is a square root. You have sine, cos, tan, exponential. Now, here, this is the part that's, you just have to pay a little bit of attention to this one, first, or just remember it. Log 10 is what the calculator does as log. So that's log base 10. And log is effectively ln. So it's a natural logarithm. So in MATLAB, they don't write it as ln, but when you write log of a number, it's actually ln. And if you write log 10, that's when you're doing log base 10. The default in MATLAB will work in radians. So sine, cos, and tan will all work in radians. If you want to calculate it in degrees, or if you want to do the cos and sine in degrees, you have two options. One, you can convert your angle from radians to degrees by multiplying with a 360 on 2 pi, etc. Or you can use commands sine d, cos d, tan d, and this one works in degrees. And a sine, a cos are all the sine inverse and all. You also have these commands, round, seal, and floor. They are all commands to round numbers for you. So round will just round the number. Then you have seal and floor, which round or gets to the next integer, or the bottom integer, as in round to the next one up or next one down. So these are, again, trials of a few of the commands. You can remember from show you that. On Tuesday, I told you that you can use the command help. So if you're not sure, for example, what something is, so help, and let's type seal. Okay. So it tells you seal rounds towards plus infinity. So seal x will round the elements of x to the nearest integer towards infinity. So it goes to the next one up. So even if your number is 1.2, so let's try. It rounds it up to the next one. So that's 3. Again, there might be situations whereby you end up using this, because even if you have, for example, if you're calculating population, and you end up with an answer of 28.1 people. So there's no such thing as 0.1 people. So then you can't do 28 because you're less than the required amount. So then you go to 29. So these are just little examples of when you can use them. So help will just give you a summary of what that function is. You also have another one called doc. Now, when you do doc, what it does is it opens up the help library, and it gives you what seal is, gives you the syntax and the description, just like, because the help command, it just quickly gives it to you in the command window itself. This one opens a new window, but it also gives you examples. So it gives you examples of how to use the command. And it can also tell you, you can look up other commands that may or may not be relevant to you. So floor, round, fix. So again, even I don't know all the commands in MATLAB. What you'll find is the more you use the help, you end up learning a lot of other commands. And every single year, we actually learn a lot of new commands from students. Like, just see a student using some random command, and then it actually does the job or solves the problem and things like that. So you will learn a lot of commands by using the help file. So you also have inbuilt commands, so like pi in itself will actually give you the value of pi. If you want to know in your program what variables that you've used, you can use the command who. So the command who will tell you all the variables that you have used into your program. So it can't be right, yeah? Students asleep. Greater than 15, yeah? What is it today? Friday afternoon. Yeah, all right, so 80. Yeah, all right, pick one. So basically, you know, you have, if you type the command who, it will tell you that your variables that you've used are number of lecturers and students underscore asleep. But this can be handy, especially when you write very large programs. And when you write a large program, sometimes you're writing them into different days, or you get few people helping on it. You write code and then shift it to someone else to write. Not plagiarism, but part of the whole system. So you can type who to see all the variables that the person has used. So that way, you make sure that you don't reuse the same variable unless you actually want to overwrite it. Otherwise, you can use different ones. So then, clearing the command window, so that one, we went through that earlier. The CLC command will actually clear the command window. You have clear that will delete all the variable. You have who gives you the list of the existing variables. Whos gives you the variables and it also gives you the size. Now, giving the size is more relevant when you actually learn about memory allocation. I think I briefly mentioned that on Tuesday about how sometimes when you write, especially when you write very, very large codes, you can end up in situations whereby you either run out of memory or you're using too much memory. So you want to allocate, for example, if you know the variable A is only going to contain numbers 1 to 10. So you can allocate just a specific amount of memory to that variable. So in which case, then when you use the command whos, it will give you all the variables and their size as well. Okay. And these, useful keyboard shortcuts. So the MATLAB help, again, we went through that already. So just while we were doing the example before. So if you type the help file in the command window, it will give you the help, but it will not give you examples. So this is mainly good for if you just want to roughly know what does this command do. If you want to know how to use the command, then you need to use the doc, or you go to the actual help itself. This also works if you don't know the name of an inbuilt function. Because help and doc, they are handy if you actually know what you're looking for. However, let's say, for example, if I gave you a question that says, can you round this number to the next second integer or the next even integer, for example? You don't know what command to use, so how would you know what to look for? Well, you can either go to the product help and type it in, or the best one to use is Google. Seriously, you try it. Like you go in there, you probably won't even need to type the whole thing. As you are halfway through, it will auto-complete it for you. And most likely, it will show you how to do it. The internet has a lot of information about MATLAB. And you will be amazed by how many things you can find there. It's like how to do this, how to do that. They will even have YouTube videos that show you bit by bit what to write, what to do, and everything is just crazy. So now, if you're going to try to solve a simple problem with MATLAB, now you'll have a similar question like this for your lab next week. all of you hopefully would have done this problem. Yeah? This is called a Pythagoras theorem. So you have a, what do you call it? Like a 90-degree or right-angle triangle. And if you want to find the length of the hypotenuse, it's the square of 12 and the square of 15, adjacent and opposite, and then you square root that. Okay? This is basic mathematics theories. So if you're doing this on pen and paper, you will probably write it like this. And then you will solve that question. When you do it in MATLAB, you need to write the correct syntax. So this is the syntax for using power, and this is the syntax for square root. So at this stage, you will find that MATLAB is very similar to Excel. This is me assuming that all of you have used Excel. Yeah? Good. So you can use MATLAB to check your answer. So once you get your answer of A, you can try whatever the answer is, 13. So if you put it A squared minus this, it will give you 0. So you know you're correct. Now, this is an example of where MATLAB is also handy. Designing a robot for the US military to carry equipment on Mars. That's basically what rugged terrain is, right? So how do you do that? So the first step is you got to establish what you want to do. So we want to create the 4-legged robot. It has to carry 155 kilos while moving at 7 k's an hour, and it should be able to go that sort of slopes. When we say go up 35-degree slopes, it's got to have enough sort of power to go that without topping over. So this becomes the mathematical problem now for us to do. So you create that, and imagine when you are walking. So I think, in fact, there's a very cool YouTube video about this on the quads, like the drones. So if you have a look on that, I think it's on TED TV Talk. You see this guy that used like a quad, and it hovers like using all the simulations. So it has multiple calculations per second that tells the drone how to stabilize itself. Now, if you are walking somewhere, you know what to do. So you know how to walk. You know when there's stairs to go up the stairs. If you see like a slope, you know that you have to put more power in your legs to go up, and so forth. But you do that, it's basically the computer in your brains that's doing that. However, when you create an artificial intelligence, or you create a robot that will do that, you need to make sure that the robot can do the same thing. So the robot then, what it can do is it uses sensors. So it uses a sensor and finds if there's a stairs, it has to go through a mathematical model to tell it, what should I do in this case? If there's a gap, like there's a hole, so it uses a sensor and finds there's a hole, it should have a mathematical model that tells it, stop, don't go in the hole. So all these things can be done with programming. Very, very complex, but can be done. So extensive amount of programming can enable this robot to actually navigate through something. So in fact, all of these, they are actually, before you actually design the prototype, all the codes are written and they are tested, and then it goes into full production. So hopefully one day can do that. So this is basically, the reason I showed this before was just to bring you to the steps involved in problem solving, especially for our case. So the first step is describe the problem using mathematical models. Now, most of step 1 we are going to do for you. So basically, we give you a problem. If it's a bit hard, we'll break it down into the mathematical models. This is where you make assumptions. So we can make a list of assumptions depending on how difficult we want it to be, or how difficult we want our solution to be. So once you've established what is the problem, what do you have to do? What's the mathematical model that needs to be applied? Step 2, you need to write the MATLAB code for it. Because you have all the steps. Now you just need to translate that into some coding. Once you write the code, obviously you check your solution in MATLAB. If possible, you try your solution into a real-world experiment. So that's when you do a bit more sort of prototyping. So you see whether it's actually doing what it's meant to or what you wanted it to. So the MATLAB code effectively does all your simulations. So you write the code, you test it, you try until you're happy with it. Then you make a prototype, test it. If the robot falls in the hole, then the model is wrong. It's time to wake up. So, I think our model goes from 89 sleeping students to 79. So yeah, if your model is wrong, then you go back to step 1 and try to figure out what's the mistake. Where did we go wrong? Was it the model itself? Was it the coding? Was it hardware failure? Could be a number of things. But you do that until you get it right. Something a bit more related for you. When you do your labs, okay, surely you're going to have questions. All right? However, what I want you guys to do is, when you have a question, the first step is try to find a solution yourself. Remember, all the labs are assessments. Okay? We are not going to give you solutions sort of just on a plate. You need to try and find a solution. Told you. So lecture notes, textbook, unit guide, that etc. Google, forums. There's plenty of places you can try and find how to solve a problem. Have a solid try at the problem. So don't give up straight away. Make sure you give it a good try. Take your time, write down the steps. How come everybody wakes up just when we get to that part? Sleep. So have a solid try at the problem. Make sure you really try. Maybe not in the first week, but as the weeks go by, you will find that some questions can get quite challenging. You need to break the questions into multiple parts. Understand what is required. Try to solve each part at a time, and then you combine it together. Few more minutes, guys. Step 2. We are going to run a faculty first year learning center. Okay, so I will send out an email. It will be on Moodle as well, but we send out an email. There will be 3 hours per week available for Eng1060 in the first year learning center. There'll be someone there where students are welcome to just walk in and ask any questions that they want about the course. We also have discussion board on Moodle. Now, for myself, this is the preferred method of contact, or not contact, but where you can get most help. I generally try to monitor Moodle on a daily basis, especially when we get in a few weeks into the course. And when students ask questions there, I'll try to answer or try to provide help on Moodle discussion board as much as I can. And finally, your last step is you can actually ask us directly. So you can email me or email the lecturers, arrange for a time, and if you want to you can ask any questions. So, general questions. Okay, again, post on discussion board. You'll find on discussion board even other classmates, meaning yourselves. You're welcome to answer any questions. Obviously, I will be monitoring it. If you've answered it wrongly, then I will rectify that. But you can, help your friends as well. Now, one last thing before you go. With the labs, again, labs will start on Monday. You will be marked straight away from Monday itself. Make sure you are allocated to a lab session. If you have any conflicts with your timetable, you need to see the faculty office and try and sort it out. And remember, don't ask solutions for future labs. They are all assessments. All solutions will come out 2 weeks after the lab has been finished. Okay, so this is your to-do list now to get ready for week 2. Okay, that's it guys. Have a